It's not particularly relevant to our story, but in May 1967, the man who started the Vinland Map saga in the 1950s, Enzo Ferraioli, and his collaborators lost their appeals in the case of the thefts from Zaragoza's Cathedral Library, and his sentence of 8 years and 1 day in prison, plus a 4.5 million peseta fine, which was about $75,200, was confirmed. On the 27th of August that year, he died, apparently of natural causes. Back with the science. The British Museum scientists spent months after their initial testing trying to find any examples of medieval inks with characteristics matching what they had observed on the Vinland Map. In 1968, they reported to Yale that they had found no match and recommended detailed analysis of the ink. At the time, that meant taking samples, but not necessarily large samples. Yale approached the Chicago laboratory founded by microscopy specialist Walter McCrone, and their negotiations came to a slightly odd conclusion. Rather than take samples immediately and apply all currently available tests, then try further techniques as they became available, McCrone Associates would wait for the next generation of analytical equipment before beginning work. Meanwhile, the published proceedings of the 1966 Smithsonian Conference were delayed for unspecified reasons, and contrary to the original intention declared in 1967, the results of the British Museum investigation were not published by Yale, nor was the British Museum permitted to publish them. Throughout the rest of the 1960s, although the British Museum team went on quietly and unsuccessfully comparing their analyses of the Vinland Map ink with every new type of ink that they saw, including every known medieval ink from Iceland, the only person publicly involved with the investigation of the Vinland Map was Jacqueline Olin of the Smithsonian Institution. Having made her name with the compilation of databases to identify the sources of pottery by chemical analysis, she now sought to use the Vinland Map conundrum to encourage the creation of a similar database for medieval inks. There was one odd thing about the way she promoted this concept, as seen in the paper she presented to the first Georgetown University Conference on Surface Analysis in October 1969. She dismissed the newspaper reports of the British Museum analyses as erroneous, which, for the reports I have seen, is a most unfair assessment. They accurately reported the only information they were given, namely that the map ink, unlike the companion volumes, lacked iron. You now have a need to know what the British Museum found back in 1967. So here's a summary. There was little or no iron in the Vinland Map ink, but plenty in the inks of the companion texts. This was first established by inspection under ultraviolet light, and would have been obvious when Yale had used ultraviolet several years earlier if they had known what to look for. The parchment on which the map was drawn looked similar to that of the companion texts and had probably always belonged with them, but it had been thoroughly soaked in some unknown chemical, having a pale colour under normal light and a very odd appearance under ultraviolet light. Also, it looked as if the two halves of the map might be completely separate, held together only by the binding of the volume in which they had been bought. Microscopic examination of the wormholes in the map showed that, at some point, unlike the companion texts, the map had been washed. The main outlines of the map seemed to consist of a pale brown line and remnants of a separate black line, looking like ordinary pencil, which sometimes strayed away from the brown onto the bare parchment. However, in the most finely detailed text on the map, the black was effectively absent. British Museum scientist David Baines-Cope noted that what we now think of as ordinary pencil did not exist until several decades after the voyage of Columbus, when a graphite mine was opened in northern England. Earlier pencils had used substances like silver, which would have shown up under ultraviolet light. The 1966 conference report was eventually published in 1971, and in 1972 McCrone Associates took delivery of an ion microprobe system, which they hoped would be their ultimate tool for analysis of the Vinland Map ink. Their eagerness to try the new equipment on the Great Mystery was, as it turned out, unwise, because they did not give themselves time to learn its characteristics and quirks. Also, Walter McCrone personally was over-keen to use the case to show the advantages of his speciality, polarized light microscopy. However, they also applied a number of other techniques to the analysis of their minute samples and quickly found something very odd. Although, as the British Museum had claimed, the map ink contained much less iron than the inks of the companion documents, it contained much more titanium. The McCrone team focused on this, quite literally, as they used both light and electron microscopes to reveal that the titanium was in crystals of anatase titanium dioxide, which they described as smooth, rounded rhomb shapes, identical in shape and size to the modern commercial pigment. Their examination of the ink lines came to the same conclusion as the British Museum, that there were separate brown and black layers, the latter being on top, most of it apparently having been deliberately flaked off to simulate natural wear and to get rid of the parts which were most obviously out of line with the brown. On investigation, they found that pigment anatase would not have been available before 1917, and that it was manufactured by an extremely complex process. The results were duly notified to Yale, who decided that now was the time to go public, but in a slightly odd way. The core of the revelations was a symposium on the Vinland Map, held not at Yale, but at the Royal Geographical Society in London. There, at last, the results of the 1967 British Museum tests were revealed, followed by McCrone Associates' analyses and studies. Americans just got press announcements from Yale, where, behind the scenes, Lawrence Witten, the book dealer who had brought the map to America, was forced to admit some of the lies he had told. It seems he rebuilt his business over the next few years, energetically resuming the issue of catalogues which he had abandoned in 1962. When Jacqueline Owen at the Smithsonian was informed of the McCrone results, she decided to check whether the claim about the complex process for manufacturing anatase was strictly true by investigating some old ink recipes. Disregarding the lack of iron found in the ink, she focused on the manufacture of a common ingredient called green vitriol, which was an iron sulfate. An iron ore called ilmenite contains titanium, and in the course of manufacturing green vitriol from ilmenite, Mrs. Owen was able to generate anatase as a byproduct. She asked her Smithsonian colleague Kenneth Toe, a specialist in mineralogy, to check how closely her anatase matched the crystals in the Vinland Map, and he reported that the size range was similar, although the crystal structure was less well defined, so further work would be well worthwhile. He examined the McCrone report in detail and found various inconsistencies and worrisome aspects, but could not argue with the central finding of well-crystallized anatase. On 12 December 1974, Dr. Toe visited New Jersey to discuss the anatase problem with chemists of the Titanium Pigments Division of NL Industries, and the following day he and Mrs. Owen inspected the map itself at Yale. Dr. Toe spotted a location on the west coast of Great Britain where the black line was very clearly drawn separately from the underlying brown. Photographs of this discrepancy have been used to illustrate the problem ever since. Also present was Dr. Carl Terekian of Yale's Department of Geology, with whom Toe discussed the possibility that the anatase might have come from clay, with which it is commonly associated in nature. The problem with this theory was that the analyses had not found significant quantities of clay minerals, which ought to have massively outweighed the anatase. The pigment chemists had shown the need for a high-temperature calcination stage to turn Mrs. Owen's imperfect crystals into something resembling the commercial product, and such a step could not have been used in the production of green vitriol. In 1975, McCrone Associates submitted a heavily revised version of their report to Yale, and there the matter rested. Over the next few years, Mrs. Owen focused on what she did best, spotting new scientific techniques which could be applied to historic artefacts, and using the Smithsonian's influence to encourage demonstration projects. In 1976, she discussed with Garman Harbottle and Ray Sterner of the Brookhaven National Laboratory the possibility of repurposing techniques they had devised for detecting solar neutrinos for carbon-14 dating on samples much smaller than had previously been possible. They put the idea into practice with Smithsonian funding, and in 1978 they successfully dated wood samples, the precise age of which was known from tree rings. News of this and other developments in small-scale carbon dating reached the British Museum Laboratory, where Richard Burley became the resident specialist. In 1983, he and David Baines-Cope published a paper in the journal Radiocarbon, summarising the possibilities and pitfalls of the new techniques. One of the biggest pitfalls they identified, with eyes firmly on the Vinland Map, was the use of genuinely old parchment or paper by a modern forger. As they wrote, It is the application of the ink alone that dates the document. It would be difficult to obtain an adequate sample of the ink itself for carbon-14 dating, and, to add to this difficulty, ink may sometimes contain dead carbon. The only unequivocal application of radiocarbon dating to documents appears to be for invalidation purposes, where a document purporting to be much earlier was actually made from material incorporating artificial carbon-14 derived from thermonuclear weapon tests. Mrs. Olin had at that time no interest in carbon dating the Vinland Map. In 1981, however, a laboratory at the University of California, Davis published some interesting analyses of old documents using a quick and non-destructive technique called particle-induced X-ray emission, or PIXI for short. This would potentially be an easy way to get a second opinion on the Vinland Map's bizarre ink chemistry. In 1982, she asked Kenneth Toe to write up a summary of his 1974 work correcting the McCrone report for Yale research librarian Marjorie Wynne. Also, at least one scientist from UC Davis, Gregory Muller, examined the map at Yale and proposed a straw-clutching variant of Mrs. Olin's ilmenite theory. After the PIXI team, led by Professor Thomas Cahill, published a groundbreaking analysis of the inks in a Gutenberg Bible in 1983, preparations began for a detailed analysis of the Vinland Map and its associated documents. Then, in January 1985, they were taken to the laboratory. What happened next will astound you.